This video introduces neural network classifiers. Neural network classifiers produce output that estimates Bayesian theorem probability P of a class Ci for a given sample X. A classifier assigns the class Ci to a sample X if this condition is satisfied. Using Bayes' law, Bayesian probability is computed by using this formulation, where P is likelihood and this prior. Px is omitted since it's not related to the class C. Although the posterior P can be computed using likelihood and prior, we introduce how to use a neural network to predict the Bayesian probability P. A neural network generates a Bayesian probability when the network output is a probability distribution over classes, and the causal function is used to train neural network to push the network output close to the distribution of ground truth, as shown here. A neural network is trained to find model parameters by minimizing the following squared error causal function here. E is the expectation over samples X in the training dataset. The joint probability P of X and Ci indicates the probability of an input class pair. Using Monte Carlo approximation and this margin relationship, the expectation above is written as an integral formulation here. For our input class pair, the term here is different between the prediction and the ground truth, which is weighted by the joint probability. Using the chain rule, the equation above is rewritten as here. Using the constraint summation of P is equal to 1, the causal function becomes here. We write this sum as expectation here, and this sum as expectation here. Adding and subtracting E squared, adding and subtracting here, and use the definition here. We can express this causal function as a sum of two expectations. Since the second term is independent of the network output yi, we only care the first term to optimize the network parameters. The first expectation term is the mean squared error between the network output yi and the conditional expectation of ground truth di. For one-hot programs, di is equal to 1 if x belongs to class Ci and 0 otherwise. Therefore, the conditional expectation becomes a Bayesian probability. Namely, when network parameters are chosen to minimize the squared error causal function delta, the network output is the estimation of Bayesian probability. For more details, please check with these references. Thank you. Bye.